Review of linear equations. Here are two examples like question 1. The goal here is to find the slope. The reason I did two examples is I want you to notice that one of them has positive slope and the other negative slope. Look at the question. Find the slope of the line and write your answer as reduced fraction. It's not going to be undefined slope. An undefined slope is when you have a vertical line, when it goes straight up and straight down. To find the slope on these, you have two options. You could find 2 points that are obviously grid points, like these two. This is the point 0, 4, and this is the point 2, 0. You could use the slope formula. The slope formula says that you do y2 minus y1, subtract the y coordinates, and below you subtract the x coordinates, x2 minus x1. So if I use these points, subtracting the y's would be 4 minus 0, and subtracting the x's would be 0 minus 2. Notice that that's 4 over negative 2, or negative 2. Now negative 2 is negative 2 over 1, but this simplifies to negative 2. Let's just observe that the rise over the run is negative 2 over positive 1. In other words, in this graph, I go down 2 and over 1, down 2 over 1, 2 down and 1 to the right. If you look at the other one, I'm not going to use the slope formula this time. I'm going to find 2 points that are clearly on the line. So I'm going on up till I find another one. Looks like right here and right here. And I can see that I go up 2, that's plus 2, going up is positive, going down is negative. And I go right 1, that's plus 1 to the right. And the slope is rise over run, it's 2 over 1, which is 2. Notice that this example on the right has positive slope. The line goes up and to the right. And the example on the left has negative slope because it goes to the right and down. Question 2. This is a horizontal line. A horizontal line has slope 0. If you're not sure why that is, remember to find slope, we pick 2 points on the line. They can be any 2 points, anywhere. This is the point 1, negative 2, and this is the point 5, negative 2. And if I use the slope formula and subtract the y's up top and the x's below, this becomes negative 2 minus negative 2. Notice the double negative over 1 minus 5. That's really negative 2 plus 2 over negative 4, which is 0 over negative 4. And 0 divided by anything is 0. The slope of this is 0. A slope of 0 is like the floor. It's flat. It's a walk in the park. I always tell students it's like the floor. And think of the word floor and remember that it has 2 zeros in it. Question 3 is a vertical line. If we wanted to find the slope using points, we randomly pick 2 points anywhere on the line. This is the point 2, 6, and this is the point 2, 2. And I could subtract the y's up top, that's 6 minus 2, and the x's below, 2 minus 2. That's 4 divided by 0. Then you need to remember you can't divide by 0. This is not possible. In mathematics here, we say the slope is undefined. Question 4, find the slope. We'll use the slope formula. We'll subtract the y's up top and the x's below. So we're going to subtract negative 11. Now notice the subtraction is completely separate from the sign on the number. Negative 11 minus negative 12 over, go back to the same point, that's the 7, 7 minus 3. This is negative 11 plus 12 over 4, which is 1 over 4. The slope is 1/4. Slope is always a fraction. It's rise over run. Always check to make sure your fraction is simplified, that it's reduced, that there are no common factors between the numerator and the denominator. If you had a slope like 4 over 8, you'd have to remember that they both divide by 4. Divide 4 by 4, you get 1. Divide 8 by 4, you get 2. Always make sure your fractions are reduced or simplified. Question 5. Find the slope of this line. There are a couple of ways we could do this. We could generate some points. An easy way to generate points is use 0, 0 for y and 0 for x, and then we could take those points and put them in the slope formula. But probably the best way to do this is remember that if we solve for y, the slope just sits right in front of the x. Y equal mx plus b, and we're looking for the m. We'll take this equation, negative 4x minus 5y equals 28, and we'll get y by itself. The first step is to move the negative 4x to the other side. We'll do the opposite to move it. We'll add 4x to both sides. We get negative 5y equals, and we'll pop that 4x right in front. 4x plus 28. Remember that we're heading for mx plus b. We're going to put x first. We'll divide everything by negative 5. And this becomes y equals, I'm going to move the negative to the top, negative 4/5 x minus 28/5. What we're looking for is the slope. The slope sits right here. Find the slope of the line. So make sure you identify the slope. It is negative 4/5. Question 6. Find the x and y intercepts. Question 6. We're going to find the x and y intercepts. First thing I want to point out is look at the graph here. We have the x-axis and we have the y-axis. And notice that if a point is on the x-axis, here for example, that is x is 2 and y is 0. And if I pick any other point, like right here, notice that x is negative 3 and y is 0. The important thing is to recognize that if you're on the x-axis, you don't go up or down at all, and y is 0, meaning this point is going to be something, comma 0. On the y-axis, if I pick a random point, here's the point, x is 0 and y is 2. Down here is the point, x is 0, y is negative 4. Notice for the y-axis that x is 0 because I don't go left or right at all. I'm right on the y-axis. X is always 0 and y will be some other number. So the y-intercept is going to be 0 comma something. All we need to do then is plug these values in the equation. We'll take the equation negative 2x plus 5y equals 20, and we'll plug in y is 0. Negative 2x plus 5 times 0 equals 20. Well, 5 times 0 is 0. That's just negative 2x equals 20. We'll divide both sides by negative 2, and we get x is negative 10. The x-intercept is negative 10, 0. Let's repeat that for y. Take that same equation, and let's plug in x is 0. Negative 2, put in x is 0, plus 5y equals 20. Negative 2 times 0 is 0. That leaves us with 5y equals 20. We'll divide both sides by 5, and we get y is 4. The y-intercept is the point 0, 4. Question 7. What they've done is they've given us an x value and a y value, and they want us to find the missing coordinate using this equation. X is 12. We need to know what y is. In the second point, we don't know what x is, and y is 15. So we'll take this point and we'll do 5x minus 6y equals 30, and we'll substitute in for x 12. 5 times 12 minus 6y equals 30. That's 60 minus 6y equals 30. We'll subtract 60 from each side. Negative 6y equals negative 30. Divide by negative 6, and y is 5. This then is the point 12, 5, and it's on that line. For the next point, we'll substitute in y is 15. 5x minus 6, and we're going to put in place of y, 15 equals 30. 5x minus 90 equals 30. We'll add 90 to both sides. 5x equals 120. Divide by 5, and we get x is 24. The second point is 24 for x and 15 for y. Question 8 is a really quick one. We have the slope, that's the m, and the y-intercept, that's the b, and we're asked to make the equation of the line. We'll put that in slope-intercept form. Y equal mx plus b. All we need to do then is substitute in for m, 1/2. Substitute in for b, negative 9. So this is plus negative 9 or just minus 9. And there's our equation in slope-intercept form. The reason they call this slope-intercept form is because we can easily see the slope and easily see the y-intercept. Question 9. Find the equation of the line, and we're going to do it in point-slope form. Point slope is y minus y1 equals m times x minus x1. The common mistake here is to mess up the signs. In our case, it's 6, 5, so we don't have that problem. It's going to be y minus 5. Remember that if that had been a negative 5, it would have been y minus negative 5, which would have been y plus 5. The only way you can get a plus here is if one of the coordinates is negative. You end up with that double negative. Y minus 5 equals m, that's negative 8/7, times x minus the x of the point. If this had been negative 6, it would have been minus negative 6, and that's plus 6. But in this case, it's just minus 6, since both coordinates are positive. Question 10. Find the equation of the line that passes through those 2 points and give your answer in point-slope form. To use point-slope, we need a point, we have 2, and the slope. We don't have that. But we can find the slope. We'll subtract the y's up top and the x's below. That becomes negative 6 minus 4 over 6 minus 2. That's negative 10 over 4. Notice that this simplifies. They're both even, so we'll divide them both by 2. Make sure you're always checking that your fraction is simplified. These both divide by 2. I get negative 5/2. Now I'll put that in point slope. Y minus y1 equals m times x minus x1. That's y minus, I pick a point. I'm going to pick the first one. Y minus negative 6. Notice the double negative. That's going to become y plus 6 equals m negative 5/2 times x minus the x of the point, which is 6. This is point slope form. We are done. Question 11 is just like the last one, except for when we're done with point slope form, we're going to solve for y and put it in slope intercept form. Get y by itself. It starts off the same. Let's find the slope. Subtract the y's up top and the x's below. That's 4 minus, notice the double negative, negative 2 over negative 9 minus 9. That's 4 plus 2, which is 6 over negative 18. Notice that 6 and 18 are both divisible by 6. This fraction simplifies. Divide by 6, you get 1. Divide by 6, you get 3. And we have one negative, so our slope is negative. There's our m. Now we're going to use point slope. Y minus y1 equals m times x minus x1. I'm going to pick my first point. You could use either one, though. Y minus the y, that's 4, equals m, negative 1/3, times x minus the x, which is negative 9. X minus negative 9 is become x plus 9. It's a double negative. The only way we can get a plus here is if one of our coordinates is negative. Now we'll distribute. Y minus 4 equals, take the 1/3 to both. We're going to solve for y and put it in slope-intercept form. Negative 1/3 x. Negative 1/3 times positive 9 is negative 9/3. But yes, that simplifies. It becomes y minus 4 equals negative 1/3 x minus 3. And I can get y by itself. I just have to add 4 to both sides. And we get y equals negative 1/3 x plus 1. Question 12. Write the equation in standard form. Standard form is when you have the x's and y's on one side of the equation, ax plus by equals c, and there are no fractions in standard form. So the first thing we like to do to make this easier is let's get rid of fractions. There's no parentheses. We don't have to distribute. So we'll multiply everything by 5. We'll take the y by 5. We'll take the negative 4/5 x by 5. And we'll take the 4 by 5. These 5's will cancel because 5 divided by 5 is 1. When I multiply by 1, that doesn't have any effect on anything. So we're left with 5y equals negative 4x minus 20. Now you're almost done. All you need to do is move the 4x to the other side. So this is a negative 4x. I'm going to add 4x to both sides. I can't add the 4x and the 5y. They're not like terms. And we're going to put x first because it's ax plus by. That's 4x positive, positive 5y plus 5y equals negative 20. And this is standard form. Question 13, also a standard form question. We're going to get the x's and y's on one side, the number on the other, and we're going to remember that there are no fractions in standard form. Now we'd like to get rid of fractions right off, but a safer way to do that is to distribute and get rid of those parentheses first. Then we'll get rid of fractions. This becomes y plus 63 equals 9/7 times x is 9/7 x, and 9/7 times 35 is 315/7. Notice that the 35 is over 1, and I only take 9 times 35, and then I put it all over 7 times 1. Now we can safely get rid of fractions. We'll multiply everything by 7. The reason we do that is that allows us to cancel on the right side of that equation. The 7's are gone. We get 7y plus, I'll take 63 times 7, and I get 441. equals 9x plus 315. Now, at the last step we need to do is move the 9x over with the 7y and move the 441 over with the 315. What we'll do then is we'll subtract 441 from both sides, and we'll add 9x to both sides. Our final answer then is positive 9x plus, that's a positive 7y, plus 7y, equals, and we'll take 315 plus negative 441, and we get negative 126. Question 14. Write the equation in slope-intercept form. This is a quick one. It's only 2 steps. We'll write down the question here. 6x plus 7y equals negative 42. Slope-intercept form is y equals mx plus b. We're going to get y by itself. First thing we do is we move the 6x to the other side. This is a positive 6x, we'll minus 6x. We're going to put that right in front. That gets us 7y equals negative 6x minus 42. Almost done. Because there's multiplication right here, to get the y by itself, we divide. We use that inverse operation. Y equals negative 6/7 x minus 6. And there's our answer. Question 15. We're going to put this in slope-intercept form. That's y equal mx plus b. Get the y by itself. First thing we'll do is distribute. This becomes y minus 2 equals 1/9 times x is 1/9 x. And 1/9 times 4 is, the numerator is 1 times 4. That's 4. And the denominator is 9 times 1, or 9. Last step then is to add 2 to both sides. And what we're going to do is punch this in the calculator. Negative 4/9 plus 2. Negative 4/9 plus 2 is 14/9. We get y equals 1/9 x plus 14/9. The slope is in front of the x. That's 1/9. And the intercept is the b right there. That's 14/9. Question 16. Use intercepts to graph the equation. Earlier in this assignment, we found intercepts, and the secret was to put zeros in the diagonal. If you're looking for the x-intercept, y is 0, because you don't go up or down in the coordinate plane. If you're looking for the y-intercept, x is 0, because you don't go left or right in the coordinate plane. If we plug 0 in for y, what happens is this term is just gone. And I'm left with the equation 2x equals 4. And I'll divide by 2, and I get x equals 2. The x-intercept is 2. Let's repeat that, and let's plug in x is 0. 2 times 0 is 0. This term will just be gone. And I'm left with 4y equals 4. I'll divide both sides by 4, and I get y equals 1. The y-intercept is 0 for x and 1. Then we'll use a ruler and draw a straight line. There's the graph of 2x plus 4y equals 4. Question 17. Remember that y equals mx plus b when y is by itself. The slope sits in front of the x. In this case, it's 4 over 3. This is the rise, and this is the run. If the rise is positive, we'll go up. If the rise is negative, we'll go down. If the run is positive, we'll go right. Think of the x-axis. If the run is negative, we'll go left. Students have trouble with this a lot. Remember that the run is the x and the rise is the y. And if you look at the y-axis, notice if the rise is positive, you're going up, just like the y-axis. If the rise is negative, you're going down, just like the y-axis. And the run is x. If the run is positive, we go to the right. And if the run is negative, we go to the left. The last thing we need to notice is the b. The b here is -3. That's the y-intercept right down here. The reason for that is, remember, if you're looking for the y-intercept, x is 0. And if I put in 0 in that equation, right, for x, 0 times 4/3 is 0, and y would be -3, giving us the point 0, -3. From here, I'll use my slope of 4/3, and I'll rise. I'll go up 4, 1, 2, 3, 4, and run 3, 1, 2, 3. Use your ruler, and there's the line. Question 18 is a really quick one. We're going to graph, just like we did on the previous one, with a point. This time, though, the point is not the intercept. It's the point -3, +2, right there. And then we'll use that slope, -1/2. Now, either you need to move the negative up top, -1/2, and this will be your rise, and this will be your run. If the rise is negative, we go down. If the run is positive, we go right. I can also move that negative below. It'd be 1/2. Notice the negative does not go to both. It either goes above or below. And if I do this, my rise would be +1, which would be up, and my run would be -2, which would be left. What you need to notice is that either one of these produce the same line. Let's try it. The top one, I'm going to rise -1 and go down 1 right there, and run +2, we'll go 2 to the right, and there's my next point. If I use the second one, I'll take my point and I'll go up 1, rise 1, and run -2, that's -2 to the left, and there's my point. Notice those 3 points, they're all on the same line. That is the graph of the line that passes through the point -3, 2, and has a slope of -1/2. Notice the way the line goes to the right and down. That's an indicator of negative slope. Question 19. Let's graph x equal -1 and y equal -4. I'd like to start with y equal -4 because it's a little easier to explain. If there is no x, like this one, that means there's a 0x. This is really y equals 0x minus 4. Notice that the slope is 0. It's like the floor. It's horizontal. And the y-intercept, there's your m and there's your b, is -4 right there. So I have a slope of 0. I'm going horizontal, left and right. That is the correct graph. The thing I want you to notice is if you look at the ordered pairs, let's pick a couple. This is the ordered pair 1, -4. Here's one. It's 4, -4. Over here is the point -2, -4. And way out here is the point -5, -4. The thing to observe is that every point has a y of -4. That's because the equation is y equal -4. Y is always -4 on that line for every point. Think about what happens then if you want to graph x equal -1. X always has to be -1. It's -1 right there, but notice if I go to the left, it would be -2. If I go to the right, it would be 0. That doesn't work. I can't go left or right. What I have to do then is go straight up and straight down. Notice the ordered pairs on this line. This is the ordered pair -1, 4. Here is the ordered pair -1, 2. Down here is the ordered pair -1, -3. Again, notice that every single point on this line has an x of -1. More than that, I want to point out that there's always two variables in these equations. X equal -1 is actually x plus 0y equals -1. Notice that I can't solve for y, because if I did, the last step would be to divide by 0. That's not possible. There is no y equal mx plus b equation for this thing. But notice the ordered pairs work in this equation. If I pick any ordered pair and I plug it in, -1 plus 0 times -3, it does equal -1. That becomes -1 equal -1. Anything you plug in for y just gets multiplied by 0 and is gone, and x is always -1. The last thing to point out here is that any horizontal line is always going to be y equals -4 is a horizontal line through -4. Y equal -2 is a horizontal line through -2. Y equal 1 is a horizontal line through y equal 1. And any vertical line is always going to be an x equal equation. So vertical line that passed through 2 on the x-axis would be x equal 2. A vertical line that passed through 4 on the x-axis would be x equal 4. This applies to the next question. If you're confused on question 20, you really should go back and watch the previous question, question 19. To explain this one, what I'm going to do is just look at some ordered pairs. Students always get these mixed up. Usually they'll say, oh, this is easy, but then a lot of them get confused on the test. But the secret is to look at the points. Look at the ordered pairs. This is the ordered pair 2, -3. This is the ordered pair 7, -3. Here is the ordered pair -6, -3. It doesn't take very many points before you realize in every single point, y is always -3. In fact, this is the equation y equal -3. Another way to look at this one is y equal mx plus b. You need to remember then that a horizontal line has slope 0. And remember that b is the y-intercept. It's where it hits the y-axis, which is -3. This then is the equation y equals 0x minus 3. And 0x is 0, so it's just y equal -3. For the second graph here, again, look at the ordered pairs. This here is -7, 2. Right here we have -7, 6. Up here is -7, 10. Down here is -7, -8. Look at all these points. Notice that every single x is -7. There is no y equal mx plus b equation here because it has undefined slope. A vertical line has undefined slope. This does not work, which is why it's just an x equal equation. It's really x plus 0y equals -7. And any point I pick, like this one, when I plug it in, it becomes -7 for x plus 0 times y, -8, equals -7. Every y value you plug in gets multiplied by 0, becomes 0, and you always get x equal -7. Every point on this line will work in that equation. Our last question is related to some of the previous questions, and it all comes back to y equal mx plus b. If I have the slope and I have the y-intercept, I can easily make an equation. Notice we can find the intercept. Here b is -3, and here b is -5. What we need to do then is find the slope. So we'll pick some points that are clearly on the grid points where we can easily see that they hit, and I'm following this down, and it looks like the next one I can easily tell is right there. We'll make the triangle that we can find slope with, where we have a rise and a run. Now I'm going to start at the top point, and I'm going to count down. Now notice going down is negative. And then from there, I'm going to go to the right, and that's going to be positive. So the slope is going to be rise over run, and negative divided by a positive. It's going to be a negative. So count the boxes. I've got 1, 2, 3, 4, 5. That's -5. And the run is 1, 2, 3, 4. That's +4. So the slope, rise over run, is -5/4, which means the equation is y equal mx plus b, -5 x minus 3. For the other graph, we can see it crosses the y-axis at -5, and I'll move one direction or the other, either left or right, and I'll wait till I find a clear grid point. Looks like right there. And then I'll make the slope triangle right here. I'm going to go to the right, that's positive. I'm going to go up, that's positive. So it's a positive divided by a positive, rise over run, which is a positive. Looks like the rise is +1, and the run, I'm going to count the boxes, 1, 2, 3, 4, 5. So it's +5. Rise over run, then, the slope is 1/5. Y equal mx plus b then is y equal 1/5 x, and the intercept was -5 minus 5.